Hi, I'm very honored to be here today. I knew I'd be honored, but I got even more impressed as I listened to each speaker. And so I really appreciate the opportunity being given to a teacher from New Jersey to come share some ideas with you that might help supply you a piece in the puzzle that I guess you guys are working on. Let's see if this moves forward. There we go. I started public school teaching in 1999, and when I thought about this talk, I realized you're probably going to think that I was a little old to be a new teacher out of college in 1999. So I had a background in business that you probably should know about. The people here, who's a teacher here? And who's in business here? Okay, so I'm kind of unique in having done both. So I ran audio companies for 20 years. So I was president and chief executive officer of Harman Kardon and JBL and Onkyo. So I ran public companies. And I can say that I've taught and I've run companies, and teaching is way harder. Especially teaching 8th grade middle school science. My first job was doing 8th grade middle school science as a substitute teacher for someone on pregnancy leave. That may be the description of hell. But I went back. Every day I went home and I told my wife I couldn't do this anymore. And the only reason I persevered was I told so many people during my career that what one person can do, another person can do. And I saw all these people teaching, so I knew it was physically possible. So I stuck with it. The second year was not terrible, and the third year was actually kind of fun. I then went into public school teaching because that was in a private school. And I began in 1999 by launching a pre-engineering program at a new Votech high school. And I had 16 ninth grade students to begin the program, and the idea was I would teach them and they would go to sophomore year, and then I keep rolling it out until we had a 4-year program. And the superintendent who convinced me to take this job over a regular physics teaching job had told me about how these students had all had Algebra 1 in 8th grade, and it was going to be a great crop of students to work with. When I showed up, in reality, only 3 of the 16 students had had Algebra 1. But despite that, they were scheduled to never take algebra. They were just put into geometry, and they were put into biology, neither of which would really help with the engineering program I was putting together, which really required more physics and mathematics. So I took my 2 hours a day that every vocational teacher, whether you're in culinary or fashion design, whatever, gets with the kids, and I broke it into 3 sections where I taught them Algebra 1, I taught them mathematically rigorous algebra-based physics, and I taught them a Project Lead the Way engineering course. The second one there, the algebra-based physics, is really the big challenge. The reason I took it on is because physics is a requirement for almost every STEM subject. A lot of people think of the S in STEM as just being any science you want to throw there. Some sciences are more useful in engineering than others. Some are more foundational than others. Physics explains the basis of chemistry. Physics and chemistry are the basis for biology. So teaching the kids algebra and physics at the same time gave them what I thought of as an on-ramp to a STEM career. They were going somewhere from there. I had another problem. This is like welcome to public education. The first day of school, I got there before any other teachers because for my business background, I figured you had to be places at least 3 or 4 days in advance of opening up to make sure everything was perfect. So I was alone in the building, and I found there were no tables in my room. They had computer stations, but no place for a kid to sit and take notes or anything. So since I was the only person in the building, I just went to the faculty lounge and literally rolled 4 tables down the hallway, stuck them in my classroom, went to the cafeteria, put some chairs up, and I had a classroom. Someone did ask me the other day what happened to the faculty room, but I don't even remember. Anyway, there was no blackboard in my room, so I got to the storage room, and they had one old one on wheels, and I wheeled it into my room. So I was ready for when the kids showed up. It turned out the round tables are now like a fundamental part of our pedagogy, and I like to think that I did it by reading lots of papers on the subject and deriving the idea. But it was pure luck. But it turns out that having a lot of kids who were never that good at science and math sitting around a round table talking about it is the fastest way for them to learn. So I could teach them briefly and then have them work on problems. So this is the pedagogy that we developed, and it's all based on that experience. It turned out the pre-engineering kids loved physics. The physics course was a big challenge for me because in the United States we teach physics late, so the only mathematically rigorous books have trig or calculus. So I had to write a book that had just algebra, so that was what I was doing weekends for that year, just sitting and writing a textbook in Word and printing it out for the kids every Monday. It turned out everyone loved it a lot. Word went out to the other kids, students in all the other majors petitioned the principal to be allowed to take physics in 9th grade, and they eventually made that switch. By 2003, all the kids in the school, vocational school, the cosmetology kids, the fashion design, auto mechanics kids, were all taking a rigorous mathematical physics that represented the first half of AP Physics B as 9th graders. We had no tracking. Special ed kids sat right next to the kids who would eventually go on to MIT. We didn't care who they were. They sat around. They taught each other. By 2005, we were #1 in the state for the percentage of kids taking physics. We were 13 times the state average. We were double the #2 school in the state, even though our kids were below average in middle school in math, science, and reading. I became 2006 New Jersey State Teacher of the Year, which is a huge honor. It's 100,000 teachers in New Jersey, and God knows how they found me, but they did, and I got to become Teacher of the Year. And then the state said, well, we made you Teacher of the Year, now you got to figure out how to take your program and bring it to all the other kids in New Jersey, which is not an easy thing to figure out. Fortunately, Joyce Powell, who's in the audience, was president of NJE at the time, and she had a similar idea, which was that teachers were going to become more and more accountable for student learning, and so the union should be involved in not just wages and pensions and benefits, which is legally all they can do in New Jersey. They should be involved in curriculum, pedagogy, and assessment. She started the New Jersey Center for Teaching and Learning that year and threw me on the board, so I worked with them since then on that, and I got released from my teaching, but I'm still a teacher at Bergen County Technical High School. To do this, to launch this into the country, or to New Jersey and then the country, we had to do 3 things: get schools to stop teaching high school science backwards, develop all the materials they would need to do it effectively, and create a lot more physics teachers. This is the typical sequence of biology, chemistry, physics taught in most of our schools. Biology doesn't lead to chemistry, doesn't lead to physics. It's about equivalent to if you said French 3, French 2, French 1. It doesn't make any sense. We do it because in 1892 we started doing it and we forgot how to change. Biology and algebra have nothing to do with each other, so kids who were sitting in algebra class saying, when am I going to use this, will not get an answer by going to their science class. We do this, very simple. I don't have time to show you much else. I could tell you a lot more, but I'm down to a very little bit of time, so let's just keep going. We had to create free editable content that captured the pedagogy and the content. We had developed all this great content, but we also had this pedagogy of not having teachers talk for more than 20% of the time, having the kids work on problems around their round tables. That's now expanded to all of K-12 math through the Center for Teaching and Learning, all free and editable, 75,000 slides. So if a teacher who wants to teach anything from kindergarten to grade 12 doesn't have to buy any textbooks anymore, and it'll be better than not having a textbook because it's using interactive whiteboards and student polling devices, and it's way better classroom experience, and it saves, I estimate, $1.5 billion a year being spent a year on textbooks that could be saved from the $1 million a year we spend to develop this material. Very much in line with this first speaker about technology. In the last 12 months, we've had 4.2 million page views, 1.4 million file downloads of this material. Again, posted free, open source for anyone to use. It's now 210,000 unique visitors as of this morning in the last 12 months. All 50 states, 180 countries. All based on that premise coming out of that one classroom. We need a lot of physics teachers because you can't teach physics first to everybody, which is what you really need if you want social justice and you want a competitive economy. And right now you need about, I estimate, 36,000 more physics teachers than we have today. That would give us the number of physics teachers as we have in biology. But we just figured out the way to do that was not to try to get physicists to become teachers, but to get teachers to learn physics, because we had this really cool, effective way of anyone learning physics fast and enjoying it. We then, well, this is our, by the way, our growth. We went from one New Jersey school to New Jersey, South America, US states, and West Africa. None of the West African countries that have Ebola are visited by me, so don't worry. We're now the #1 producer of US physics teachers. We're actually almost 3 times the #2 producer of US physics teachers. We're a major producer of US chemistry teachers, and we've trained over 1,400 teachers in this method of teaching. The key thing is that now 6 of the 12 top schools in New Jersey, for the percentage of kids taking AP Physics, are taught by our teachers. Those schools are 60% poverty versus 4% for the other 6 in the top 12. 70% of the students in our schools are Black and Hispanic versus 8%, and we're in urban districts. The teachers we're creating are diverse in terms of being male and female, but also Black, Hispanic, white, It doesn't, because if you just draw from the pool of people who majored in physics, you're going to get a very undiverse audience. A key assertion we would make is that social justice and global competitiveness are two sides of the same coin. Social justice means you give every kid a chance to recognize their potential. Global competitiveness means you realize the potential of all your citizens. Take a second, you see they're the same thing. So business and the most well-meaning teacher in the world have the same interest in this. All of that requires that all students have access to physics in 9th grade, mathematically rigorous physics, followed by chemistry and biology. And if we provide that, now that, saying that global competitiveness and social justice require that is nice, but not very useful if it's not possible. We've now shown it's possible. It's just a matter of will. Who cares enough to do it? It sounds like, I've been very impressed with what I've heard this morning. It sounds to me like Utah is a place with that will. Thank you so much.